A new, large-scale computer simulation has shown for the first time that large disk galaxies, much like our own Milky Way, may have existed in the early days of the universe. The simulation, created by physicists at Carnegie Mellon University's McWilliams Center for Cosmology and the University of California Berkeley, shows that the early universe a mere 500 million years after the Big Bang might have had more order and structure than previously thought. Their findings, which will be published in the Astrophysical Journal Letters, will help guide researchers using next-generation telescopes like the Wide Field Infrared Survey Telescope WFIRST and the James Webb Space Telescope JWST as they search the sky for evidence of the first galaxies. It's awe-inspiring to think that galaxies much like our own existed when the universe was so young, said Tiziana Di Matteo, professor of physics at Carnegie Mellon. The deepest Hubble Space Telescope observations have thus only covered small volumes of space and have found very irregular, clumpy galaxies at these early epochs. It is not surprising that in these small volumes some of the small galaxies do not have regular morphologies like large disk galaxies. Similarly, numerical simulations have been limited in size, so they have only made predictions for the smaller, clumpier galaxies at these early times. Di Matteo and fellow CMU physics professor Rupert Croft have long been at the forefront of simulation cosmology, completing some of the largest simulations ever created. Their current simulation, called Blue Tides, is 100 times larger than previous simulations. It was so large that it monopolized all of the National Science Foundation (NSF) supercomputer Blue Water's memory and almost 1 million CPUs in order to complete the simulation.